I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Good afternoon, Ben.
Hello.
Thus revealing to everyone the time of day that we record this. This is how we slowly leak information about our lives. This is how we dox ourselves.
Right.
But it is indeed a beautiful, glorious spring afternoon. And in a rare departure from normal, we're going to record a podcast and then I'm going to release it in a few days' time. So we could actually make allusions to things that are happening in the news without revealing how usually far ahead of ourselves we are.
That's right. We can.
We have a Chicagoan Pope.
That's right. Chicago. We make popes. That's
a
shirt that I need to make.
Pope. I think that was the Chicago Sun-Times headline was Da Pope, which will only make sense to people who are from Chicago or in America and have seen Saturday Night Live sketches.
Yeah.
Right.
Yeah. You definitely don't have to be from Chicago to get that, but you have to have seen the Saturday Night Live sketch.
Right. As I mean, like no one in like my native side of the Atlantic will really know what the heck we're doing with that.
Nope.
But
when do they ever though is the question.
Oh, ow. What passes for comedy in this country?
It's terrible. It's like that, you mean? That joke I just made?
Yeah. You mean American makes slightly xenophobic gag? Yes, that checks out.
Yes.
Oh, this is not the direction we went to take this at all. Anyway, it's nice to see you, my friend. It's been a little while. At least, we saw each other socially not all that long ago, but across a long table with lots of other people there. So we haven't had a chance to hang out. But we thought we'd take advantage, as I recall, of the fact that this is a timely podcast and actually talk about something which is timely, which is a whole thing that blew up on the Hacker Newses and the Reddits of like some old talk of mine.
Mm-hmm.
And we should use it as a topic of discussion because I think it'll have some interesting you'll have an interesting take on it, I think. So so the talk that I gave was a few years ago, and it was my first, I think, non like compiler explorer stroke performance sensitive talk. It was just me saying, hey, I've been doing C++ a while, and what I'm really, really bad at is programming, and so these are the safety nets that I make for myself. So in order to deal with my own ineptitude, I will do these things. And they were like, best practices, essentially. Best practices, like don't just use numbers, use types that wrap numbers and don't wrap them in the trivial way because often that has unintended side effects and all these things, right? And effectively, all of them amount to C++ has some really powerful but wrong defaults that it kind of inherited mostly from C. And if you go out of your way to write code this way, then you can kind of mostly negate the bad decisions that were made. And that's, I think, how most C++ programmers survive is they ignore large swathes of the language and kind of go, let's just not do it that way. And we turn on all the warnings and the errors for things that you use that are anachronistic and say, just don't do it that way. The blog post that somebody wrote on the back of this, which was something like, how Matt Godbolt convinced me to move to Rust, which was absolutely not the intention. But the thesis was, this is just a reinforcement that C++ is a language full of anachronistic bad things. And if you have to go this far out of your way to do it the right way, why not just use a language where the defaults are right? And so, first of all, that was not the intention of that talk. And second of all, I don't know what to feel about that. It was an interesting moment. So what are your thoughts on like this whole thing? Obviously, you don't program in either Rust really or C++, but
no, I mean I have, but I don't on a regular basis. But I think this is like the classic example of as an artist, when you create something, you have no control over how your audience is going to interpret that. And I think one of the side effects of putting something on the internet is that people are going to, what you would say, misinterpret, but is just internet interpret. Like they're going to consume it, they're going to process it, and then they're going to have some understanding of it. And how much that aligns with what was in your brain when you created it and what you maybe have had in your mind of like a theoretical consumer of this information that I'm creating might think these things. That's an illusion that you have as a creator of
Very much.
things that happens or will ever happen or can even happen. And so, it doesn't really surprise me that much. I'm sure that you could find more of these of where you're like, you
I'm
clearly didn't
sure.
understand what I was trying to say at all. And maybe that's on me and maybe that's on you. But
I mean, I
the
think this
message,
was sort of willfully
right,
differently interpreted, right?
right.
But it was an interesting thought. Like maybe
Yeah.
that is and it's interesting you describe it as art because certainly, I always think of art as an expression that's designed to provoke or provokes an emotional reaction, and clearly it did
Hmm.
for this person. It was
Right.
like,
Yeah.
screw this, I'm going to
Fear.
use a different programming language. Yeah.
Yes. Uh-huh. Yes. Fear with a hint of disdain. Those were the emotions that you managed to provoke in your
In this
observer in that
observer,
instance.
yeah.
Yeah. Uh-huh.
Yeah, have you ever had something like this before? You've obviously written blog posts and things along the way, and
Yeah, I mean, I have definitely had some things where um clearly I'm not getting the point across. And I'm always torn, and I bet you have this sort of same thing of like there's so much nuance to this thing that I'm trying to communicate. There are so many sort of like edge cases and interpretations. And if I try to boil this down into something that a normal person would actually take the time to read, they are almost certainly going to get it wrong. And so, this is why I kind of like, we joke about like consultant Ben and like the acronyms and,
yeah,
cruft and fire and all of these other kinds of things. But like, I feel like the key to these is like, you have to try to boil it down to something as simple as that and then just repeat it. Because if you don't, it's just so hard to communicate like the true nuance of the thing. And so, that's kind of like my hack for like trying to do this and do it in a way that's sane is to say, can I come up with the catchy acronym for it? Because that will help it also stick in my brain. So when I'm trying to explain it to people, I'm like
you can,
explaining it in a consistent way, right?
yeah.
But also in their brain to where it's like, when I say fast, I mean tests that run hundreds of tests per second. I don't mean like, yeah, we ran our whole test suite in 10 minutes, right? Like that,
Right.
if you had hundreds of thousands of tests, that would be fast, but that's not what I'm talking about, right?
No, that's really interesting. Yeah, I'd never really kind of thought that obviously that's a didactic technique, right? For like, this is how I choose to present it. But you're like, no, if I try and present something more complicated than this, at least to start with,
Hmm.
then people aren't going to read, they aren't going to remember it. So I'm just going to have to drum in this simple thing. And then I've got the bedrock of understanding. And then we can have a nuanced discussion about, well, what does fast really mean, in this particular
Hmm.
context, right? But you at least you remember that the F means fast. So that's an important bit of the rest of, yeah, yeah, yeah.
Yeah, yeah, exactly. On the topic specifically of like Rust and C++, like, I mean, my kind of, very novice experiences with C++ have always been there are just some areas of the language that you want to stay away from. And I also, and I would be interested to hear your take on whether you think this is true, but my sort of perception of it is that there's not like really one type of C++ programmer out there. Like you very much sort of pick which parts of the language and what parts of the tool chain either fit you as an individual or maybe fit like your company or like the problem that you're trying to solve. And you pull those parts out and you use those. And then I think there might be like a pattern of people like getting like repeating that and sort of like glomming on to like that section of it. And so like, which is maybe something that is maybe less true of other languages. Like you could take two people who call themselves C++ programmers and they will agree on nothing.
That has definitely been my lived experience, very much so. And certainly, um, there is a sort of nucleation point in a company where if you have one person who does C++ a certain way, you're either going to have a really hard time if you hire someone who doesn't do C++ the same way as them. They're not going to
Hmm.
be able to work together as well, or they're going to have to work in separate code base, or you just start hiring people who all work right that way. And it's either,
Yeah.
very functional style, very template heavy, very compile timed heavy. And obviously the beauty of something like C++, such as it is that you can consider it a continuum, even if you are more like I'm just writing C with classes, very simple classes. You can say, yeah, but every now and then where I would like to use a macro in C, it is nicer to use a template to do the same trick. And you can borrow from opposite ends and extremes. But generally speaking, yes, there seems to be 3 or 4 kind of ways of
Mm.
writing C++, and maybe that's not true in other languages. I don't know. I mean, like we make the best sort of example I can think of is like Java. Java almost always seems to come across to me as very enterprise level. Everything's
Mhm.
a factory. We joke about these things.
Yeah,
Factory,
right.
get a set of things, right? Whatever.
The factory builder bean. Yeah. Uh-huh.
Yeah, yeah. Which
Yeah.
obviously I think Java has moved away from. And I know you're writing more Java these days than you were perhaps before. Um, sorry, editor Matt. You're gonna have to edit out a dog. Um, yeah, so Java has got multiple like incarnations of Java, but I think by and large, most people that I'm aware of have moved away from the very, very enterprisey bean
Yeah.
factory stuff into a slightly more sensible subset.
Yeah.
But then you think about like trading system Java, garbage free Java,
Right.
and
Yeah.
that's
That's
like,
a
oh
whole
yeah, no,
other
that's
variation.
it's
Hmm.
a completely different sub language, really,
Yeah.
of Java itself. So there is a little bit of that, but I don't think and I'm not really qualified to say, but I don't think there is the same level of like these two Java programmers just couldn't work in the same code base unless you've
Yeah.
gone, almost like the language forces you into it. Everything is OO, right? You're kind of stuck with OO because that's the way the whole language fits together.
Yeah,
Um,
yeah. I will say that it's like I have seen people write purely functional Java, but it is weird. It is not like
okay,
one of like you say. There's maybe 4 variations of sort of C++
maybe I think yeah.
archetypes. Let's just say it's 4. It's like if that was true of Java, that wouldn't be one of the 4, right? Like
It's
and
that,
I'd be
and
yeah.
in fairness to again specifically for Java or JVM languages, obviously you have
Hmm.
Clojure and you have
Right.
Kotlin, and if you want to do that kind of stuff, it's a different language and they interoperate fairly well. Like
Yeah,
so,
pretty
you
much
could do that.
seamlessly. And that would be and my exact point is like this is just a closure programmer that you forced to do Java and now they're doing everything as a function and with streams and everything else cuz it's almost like malicious compliance at that point, right? Um so that's not like a way that I would normally expect people to use the language. Whereas it sounds like certainly that the case of in C++, it's like there are, 3 or 4 different ways and you could reasonably argue about which way is better or worse in different contexts, but they're all kind of like acceptable.
I think so. Yeah, absolutely. Although this is we're sort of off the track of where I was going with this, but it seems relevant. Uh, the presentation I gave a few weeks ago at the ACCU was me deliberately writing C++ in a way that I would never write it naturally. Right, my
Mm-hmm.
particular kind of archetype is I am using sort of OO C++ with as using templates for generic programming only, not for meta programming and not for
Mm-hmm.
like very complicated type related tricks. Um, and certainly, yeah, I guess that's the best way of me describing it. And I'm not afraid to use a virtual function here and there to separate concerns. And I'm very thoughtful about how I try and separate the implementation from the interface so that I can do testing of the interfaces and compile time stuff. All right, we've talked about this kind of stuff before, but I'd
Mm-hmm.
force myself to say, no, there's a whole bunch of new cool things coming in the language or here in the language, concepts, coroutines, const expert, everything seems to begin with C, constival. I'm trying to think. There was one other thing, modules, which doesn't begin with C, but the C is silent in
Yeah,
modules.
right. Comodules.
No, it's silent. But you got that wrong, honestly. But yeah, modules. And I try to use all of these things to write a piece of code. And I was hoping, and now this is where the podcast listenership will get the secret scoop behind it. I was secretly hoping that I would write the code in this newfangled way that I gut feeling don't like. And I would come away from it and it would be universally vindicating of my previous position that actually
Right.
everything, the way that I
Mm-hmm.
did it was the right way.
Right.
Of course that didn't happen because nuance, right? This is it.
Mm-hmm.
Maybe this is the central theme of today's thing is everything is nuanced and there is no obvious one correct answer to anything. And even the archetypes sometimes move away from their archetype. Again, this blurriness around the edges, although
Mm-hmm.
Yeah. Uh, anyway, I discovered that like I couldn't actually beat the performance of my first implementation. I wrote the thing multiple times. So I wrote it once in my natural style, and then I said, okay, now I'm going to take all the newfangled nonsense and I'm going to prove that this is both more complicated and worse. And unfortunately,
Hmm.
it wasn't that much more complicated and actually has some genuine benefits, and the performance was
Yeah.
considerably better. And then at the
Yeah.
very,
Yeah.
very
Yeah.
end, like literally with a day to go before I presented it, I was up all night writing it a fourth way. I wrote it actually three ways. A fourth way, going learning what everything that I'd learned from the cool new way, trying to backport it to my original methodology, and it still wasn't actually any better. And so I was like, darn it.
Yeah.
And this is
Yeah.
a personal development journey more than anything else, which is kind of what the presentation's all about. But
Hmm.
um, yeah, I think I suppose the story here is that the don't let the archetype box you in,
Hmm. Hmm.
and don't pigeonhole yourself. Don't be afraid to try new things. I guess that's the talk's thesis was.
Hmm.
But um, as it regards to this particular thing, the archetypes uh, are potentially, there is a benefit to picking one archetype over another, or one bit, and it may be say performance. In this instance, it was perhaps look the code base is slightly more uh, co- coherent. No, what's the word when things
Cohesive.
cohesive, yeah, overly cohesive, right? In terms of like this part, no,
Coupled.
yeah, coupled. Thank you. That's the one. Again,
Yeah.
another C word. Everything needs to. This episode
Commodule.
was brought to you by the letter C and the number 5.
Yes.
No, so it was more. Everything seems a lot more coupled, which means compile times are higher, and
Yeah.
everything's more sensitive to change. But I couldn't argue with the performance increase that I got, and for some
Yeah.
applications, that's more important. It probably wasn't for
Yeah.
the one that I was doing, but it was noteworthy, and I can now see why some archetypes might choose to go that way,
Hmm.
because the importance of runtime performance is trumps the compile time or or other aspects, right?
Yeah.
And for other people, it might be testability. I was only talking to somebody earlier this week about writing code in like very critical environments,
Hmm.
like or proving correctness in say automotive or aerospace or whatever like that. And at that point, maybe you have maybe got a real-time constraint and performance, but moreover than that, you have to absolutely be able to show that it's right, and that might
Yeah.
inform the way that you write your code. So
Yeah.
this is way off the original topic, but that's our podcast for you.
Yeah. Well, there you go. Well, okay. So, like,
Let's go.
bringing
Yeah.
this back to the sort of original thing of like the post that was going around about Matt convinced me to write Rust. So that was about a talk that you gave a while ago, right? Like
Yeah, this was
when was that talk?
maybe 6, 7, 8 years ago. It's previous company, pre crypto company as well. I think
Yeah.
it was at the first finance company then. Yeah.
and maybe I lost the plot, and it's like, but the talk that talk
Yeah.
was the comparison of these three different implementations,
No,
or
no,
that
that
was a
was a
different
different one.
talk, right?
That was
Yeah.
another one. Yeah. So what
Yeah.
this
Yeah.
one's thesis was, like the talk was called "Correct by Construction," and it was me saying like, "Hey, if you write your code this way,
Yeah.
then
Yeah.
the compiler won't compile your code if you make a silly mistake." Some of the
Right.
many silly mistakes. So the one of the classic examples in that is without all of the warnings on, which you should just have on. There's no question of it. But like the default compiler will not warn if you, for example, take the example I gave is like placing an order on an exchange, send order,
Hmm.
send order, and you have float price, which you should never have. That's a whole other conversation. But like it suited my
Right.
purposes. Float
Yeah.
price and int quantity, right?
Yeah.
If you're trying to buy 100 Google shares for $1,000 each, you sure as heck don't want to switch those parameters and actually buy 1,000 shares for 100 or whatever. Sell would be worse in
Right.
this instance,
Right.
right? And
Hmm.
the compiler will happily let you write that, and it won't give you a single warning because it says, oh, this float can be exactly represented as an int, so that's fine, and this integer is fine as a
Yeah.
float. No question, you probably meant this, ha ha ha. And you're like, no, I absolutely never meant this. And so one example would be never accept naked integers and floats, because you can get it wrong. Why don't you make a
Hmm.
price class
Hmm.
that has all of the things that prices need to do, and a quantity class that has all the things that quantities need to do? They are still just an int and a float or whatever. Again, don't use
Hmm.
floats. Um, but they are now domain specific objects that have useful functionality and the compiler will tell you off if you switch them around. And then I
Yeah.
present a whole bunch of like techniques and things to make that really straightforward and easy, and even make it testable, all those kind of good things. And the take home from this chat was, why are you using a programming language which even allowed that to happen in the first place? It's great because but you could forget to do this, or you could choose not to use this approach, or whatever. And it's the same with
Yeah.
like the other classic example, which I don't think Rust has a solution, is like, what if you have a bad API design where you have 5 bools in a row as like parameters to a function? It's like you're just asking for somebody to screw the order of those things up, and there's no compiler in the world that will solve that for you, or no language. That was just a bad API design. That's how I chose to interpret this. It's bad API design. I think the take home for this blog post writer was like, why not make it impossible to make those APIs that bad? Now, again, fools notwithstanding, but yeah, go.
Yeah, my hot take reaction to this is going back to the Bjarne quote of like, well, maybe Rust just isn't used enough for people to complain about it yet, to fracture into these 3 or 4 different archetypes, because people will have very strong opinions about, oh, you should always do it this way, or you should never do it that way. Give it time, my friend, and you too will be having someone write the blog post that says, so and so convinced me to never use Rust and use whatever instead.
Zig, yeah,
Yeah, exactly.
Zig or Go or whatever is cool
Yeah.
next.
Because it's like, that's the thing, is it's like sometimes the stuff is all just carpet bubbles, right? It's like, oh, this is a problem that
What did you call
affects us
that? Sorry,
all.
we're going to have to stop. Carpet.
Carpet bubbles, you push the carpet bubble down and then it just pops up somewhere else, and then you push
Oh,
it down
yeah.
there
No,
and
I
then it
knew
pops
exactly
up
what you meant
somewhere
when you
else.
said it, but I just never heard it called that before. I wonder if that's an
Yeah.
American thing. But yeah,
Whack-a-mole is the
whack-a-mole
same
is what I would
thing.
think of. But yeah, yeah,
Yeah. Where it's like you fix one problem and you're just creating another one, or sometimes it's worse and you create 2 problems, right?
yeah,
And so like it's really, and it's really, really hard to look at that holistically and be like, okay, let's not, you want to talk about things that won't hold people's attention. Let's not look at just this one problem in isolation. Let's look at all the universe of entire possible problems and consider at that level whether C++ or Rust is the right solution here. How many lifetimes do you want to spend researching this and writing it and then reading it, right? So it's hard. But I think that it's like time is the thing that makes that happen, right? Like time is the
hmm
thing that sort of teases out like, okay, here are all of the edge cases of the edge cases of the edge cases. And the only real way that you can figure this out is to figure it out for yourself. You got to go and dive into each of these things and learn them to a pretty deep level, and then dive into the other things and learn them to a pretty deep level, and then kind of just rely on your intuition to tell you which you think is best, because it's going to be very difficult to objectively say, well, X is better than Y.
yeah, yeah. I mean, it is. All those things are true, but it is absolutely unquestionable that the C++ has tons of own goals
Oh,
from the point
yeah.
of view of like things that we all wish it would be a different way.
Mm-hmm.
But it isn't. And of course, the superpower of C++ is that I can take code from 1988 that was written, with for Cfront, Beyonder's
Right.
original C++ to C converter compiler thing, and that code will almost certainly just work in today's code. Um, that's great, but unfortunately means that all of the terrible decisions that were made back then propagate through time as well. And there have been some floated ideas about making like epochs and like scoping things with like, hey, this is using the new semantics or whatever. But like
Mm-hmm.
the problem with that is the code still looks the same, and unless you scroll all the way to the top of the file, it says Pragma edition 2027 or whatever, you don't know whether or not it's safe to go int I without initializing it or not, because maybe
Yeah.
in the old way it never and so I get it. And this is why people want to say, well, let's just use I say let's try using Rust.
Mm-hmm.
Rust has essentially has had a more modern take on what all the defaults should be, and by and large it seems to have got an awful lot right.
Mm-hmm. Mm-hmm.
And there's no way in hell you're going to accidentally think that you're reading some Rust code and think it's C++ and go, oh, this is how it works, right? No, there's no question. And nor are you going to
Right.
include a C++ file from 20 years ago into your Rust thing and expect it to work. It just doesn't.
Right.
So the
Right.
very thing that makes C++ powerful is also its sort of undoing, because we kind of
Right.
can't solve that problem. So yeah, nuance, it's subtle. Um, I mean, like right now, if I were to start a new project for something, I probably would do it in Rust myself for the same reason. I mean, partly because I have the flexibility now, as I'm not doing anything else with my time, to pick anything I darn well like. Um, but yeah, C++ is around for a long time because we use C++ to interact with the C++ we wrote last year and the year before that, and our
Right.
vendors wrote. And the interop story is still not great in other languages.
Yeah.
I don't think it's great in any language, honestly. I think C has become the standard interop for everything,
Right.
which is a
It's
weird,
the most universal one
yeah,
for sure.
which is to say, only slightly above assembly language, which obviously warms my heart.
Uh, yeah. Well, I mean, to maybe tie this off. I don't know if this is going to start a whole new branch of
Uh
discussion or
oh.
tie off the conversation. Who knows? But like, I think the value that reevaluating these things has is you get to learn from other people's experiences, aka mistakes, and say, here's a mistake that we keep making over and over again. Let's see if we can try to systematically solve it. And I feel like the almost the worst case there is that you turn it into a carpet bubble, but probably what's going to happen is you're just going to make it one big bubble turned into a smaller bubble. Right? You traded one hard problem for another problem that was probably a little easier to manage.
Right,
And
right,
that is oftentimes what progress looks like. It's not like, hey, we eliminated all the problems. Is we took all the like really terrible
right.
buffer overflow problems and we turned them into like sort of less terrible. Okay, this just takes a really long time to compile and it's hard to understand problem.
Right, right. Or Rust. How do I find a way to explain to the borrow checker that this particular set of lifetimes is in fact okay, or
Mm-hmm.
maybe it isn't?
Mm-hmm.
Or how
Yeah.
do I? Yeah, how all of my ills about who is meant to clean up this memory is solved by a garbage collector that has a different trade off. And so
Yeah.
all these
Yeah.
things, yeah, it feels like there's some kind of like, yeah, I think what you're saying, there's a sort of global minima that we're all in different little sub pockets of, and you can perhaps find a lower minima somewhere else, but it's not that clear cut. You can
Yeah.
turn one bad problem into two slightly less bad problems, or maybe
Yeah.
you just
Yeah.
trade off a thing completely. Yeah, runtime
Yeah.
performance, or yeah.
Interestingly, I was talking to a mutual Matt of ours the other
Oh,
day,
cool. Yeah,
who had told me, who's doing a lot of Rust, and who had told me that he's like kind of given up on lifetimes. He's like, I'm just not going to use them
I thought.
anymore. I use them very
I'm so
sparingly
glad
now.
that you said lifetimes. When he said he's kind of given up on life, I was like, what? I'm gonna make it
That
a
is a
phone call.
that is a very bad side effect of Rust. Is it's like a pharmaceutical commercial. May lead to suicidal thoughts. No, the
Yeah. Whoa.
no, he has given up on using lifetimes in Rust because he's just like it's just too complicated. I just
That's
don't think
really
it'll
interesting.
work.
So,
Yeah,
presumably, just essentially redesigning things so that you don't have to explain the lifetime of things
yeah.
to
It's just
anybody.
like
You
just
just
make a
give them that.
copy. Just make a copy.
Right,
That's the
which is not a
easiest thing
bad
to
thing
do.
to do either. Yeah, I
Right.
mean, and again, that's another language, Val, which became some other name. I can't think now. This is terrible. I should know all these off the top of my head. Something like that. I don't know.
I don't know.
Dear listener, Ben is putting all sorts of expressions of I don't know
Yeah,
in
no
the
idea.
video chat. But that was sort of founded around everything should be a value, which is
Mm-hmm.
very functional feely, right? And
Mm-hmm.
uh, again, that's another sort of like a different direction you can go down. It's like, hey, everything's a value, and then you're like, well, but actually, it's too expensive to keep making copies of everything all the time. So somewhere, some clever piece of code, maybe in the compiler, is kind of going, hey, we can actually use the same
Mm,
one because we know that the previous lifetime actually ended and the new lifetime began. So it's actually in this, it's still register 8. So there was no copy. We just carried on with it. Oh, it's that kind of stuff,
right.
which was always
Yeah.
the way I felt about like functional languages, where they're like, "Hey, yes, if you want to mutate a map, then you pass us the map and say set key X to Y, and we return a new copy of the map with
Right.
exactly the same." And you're like, I can't believe it's an actual copy because that would never work. And they're like, yeah, but
Right.
behind the scenes, we're doing reference counting and we're doing, careful.
Yeah. Yeah.
And you're
Yeah.
like, okay. So it's what you're saying is you're faking this for pragmatic reasons. And so
Yeah.
there is mutable state. It's just hiding inside the runtime.
Yeah, yeah.
How did you write this mutable state in your functional language, which doesn't have mutable state? Well, we wrote it in a different language. You're like, now
Yes.
I'm out.
Uh-huh.
Anyway, yes,
Yeah.
you said about rounding it off. That seems like a decent non-solution, non-description to finish on, like any of our podcasts. But
Yeah. It's either this or we talk for the next 2 hours, and that seems unkind.
that seems unkind. Yeah, I don't know. Actually, I mean, there are some long-form podcasts out there. As I've been discovering with all my extra spare time. Some, even though when I put them on like an hour, 1.5x, which I'd be interested to know if anyone listens to this, especially when we're gambling at full speed, anything other than 1x, 1.2x, maybe.
Yeah.
But yeah, we're not that long, and in fact, this is relatively short for us. So, on that bombshell, maybe we should say, always lovely chatting with you, Ben, and I will see you next time.
Until next time.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbold. Find the show transcript and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hachyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com.